manifold design. We're going to be looking at the negative build sheet. This is where the machine tool operator is going to get all of the detail information that they need to be able to manufacture the manifold block. When I look here, the first thing that we see in the far left-hand column is the letter call out for the view. So this tells me that for hole A1, what all the dimensional information is, and likewise with B's and C holes. Now, I'm going to come in here and give it a description for what this hole is, and I'm going to label that as the inlet port. It's going to give me my XY location based on the lower left-hand corner of the datum point. It's going to show me what the hole diameter is, and that's going to say that that's 344 thousandths, which is a drill size 11/32. Well, how do we get that drill size hole? I've got a reference information that I'm going to email out to you guys, and it's called fastener clearance. And when I look at it, this is information that I got off the internet that shows clearance information for holes and a lot of great information. This is what I'm looking for. Here right now is the Starrett chart, and when I look at the Starrett chart, it's showing me my drill sizes. It's showing me number drills, letter drills, and fractional drills. We need to know that those are all different types of drills. When I look at this, we want 344 thousandths. I'll zoom in here. I start looking down my list at 344 thousandths. I go 0.343, but with the 8/10 thousandths, we round this up to 0.344, which is a drill size 11/32. Any of our drill sizes that we come up with, we should be able to find them on this chart for the manufacturer. Now, I go over to my negative build material again. It says that the hole size for that is 344 thousandths, and the drill size is 11/32. Well, why is it 344 thousandths? The reason for that is if we look at the manufacturer's information for that cartridge valve, if I'm looking at a check valve that is a 2-level 8 series cartridge valve, I go over to the cartridge valve information. It says right here that the maximum hole diameter for this should be 344 thousandths. I can either find this information off this drawing, or I can use the calculation for velocity through a line. Now, I create that hole size using that drill for my manufacturing call out there. So if I go back over to my negative build sheet, that gives me that information, and it tells me what depth to do it. This first block of information tells me where to locate the hole and what size hole to make. If I look, all of these holes here happen to all be the same size using the same drill, but they're at different depths. The next thing I do is move over and say, well, what is this? And it's going to be an ORB or a cavity. This one happens to be a -8 ORB, and it tells us that even though we've drilled it, this 344 thousandths, we now need to follow up with another drill that is 672 thousandths, which is 43/64. We could go back over to the Starrett chart and find that, and then it says go to a depth of 690 thousandths and include a spot face of 31 thousandths. Our spot face is a standard depth for cartridge valves and ORB facing. This is a standard, but where did we find these? This is another piece of information that I'll send out to you, which gives us information on ORB sizing information. So if I go over here and I look at this, it says what is our dash size? We're working with a -8. It says the form tool for that from Parker is a part number Y-34735. It tells us that we need to drill a hole out to run this form tool in that is 672 thousandths, which is 43/64. That will line us up so that we can get a 3/4 16 thread in there. The form tool does not cut the threads. We need to use a tap to cut the threads, and then over here it tells us what is our depth. This information can also be found in your Lightning reference book. Going back over to my negative build material. This tells me the hole location, drill size, and depth. This tells me how I'm going to start to form and shape the tool and what I need to do to make that happen as far as drill sizes and depths that I need to go and what my spot face is. The last part is telling me what my finishing work is going to be. On this one I use an ORB finishing tool, just like was called out in that information that I just referred to from the straight thread O-ring call out. And then we're going to use a tap to cut the threads 3/4 16. Okay, every one of these holes should have a tap size, and it looks like one of them is missing right there. My mistake. I'll have to take some points off for that. Okay, so now I go in. My system ports should be the same type of form tool. All that information should be the same. And my ORB tool should have been listed out in here. Another point where I should have taken off points. Uh-oh, getting sloppy here. And then going in here and also showing what I need to tap it. So it should be the same form tool for both these ports, which is a Y34 735. And both those ports should be tapped 3/4 16. Now I get down to view C, and on these are where my cartridge valves are going. Doing the same thing, I'm going to locate where that hole goes. I'm going to drill my pathway through there, showing my depth, and then I'm going to come over here. This is not an ORB, but it's a cavity, and it's an 08-2 way valve, and you can leave the way out of there. It tells us what size drill that we need to use. That was found off of the website for the cartridge valve, telling us what size drill to use. And then I look at the Starrett chart, and it says that that is a 15-30 seconds. I'm going to say how deep I'm going to drill the hole, and a spot face, standard 31 thousandths. And then over here, when I start doing cavities, I need two form tools. The first one is a roughing tool. It looks just like a regular drill, but it's got some special geometry that's been put on there to help create those the geometry that we need. And then we run a form tool through there. Once the form tool is done, then we can go in and use our tap. Now these are -8 ORB or cavities, and these are -8 ORBs, which we use the same thread configuration as we do for all of those. So I should be able to use the 3/4 16 tap. Let me show you where this form tool information comes from. The form tool information comes off of the Hydroforce website. So if I go over to the Hydroforce website and I click on my form tools, they have a catalog page in here that tells us that the first thing we do is we start out with CT for the form tool, and then we come down and we call out what is our thread size. Since we're an 08, that would be a 3/4 16. We move down a little bit further, and then it says how many levels are there. And you can see that there are some special ones that we haven't talked about, but this is a 2-way, here's a 3-way, here's a 4-way, 5 and 6, and then some special cavities that we get into. And then the next thing we need to do is we need to call out that it is a roughing tool for the roughing tool, finishing tool for a finishing tool, and then we're just going to list out high-speed steel. If we were in high production area, we'd go to a tungsten carbide tooling and get that, and then we do G for general purpose. This gives me my tooling for cutting cavities. So negative build sheet is super important. This is what the machinist is going to actually use the majority of the time for what he's going to do. On the sheet that I send out to you, we're going to talk about how many faces we machine on. We're going to list out how many cross drills that we have to do, and then what is the block size. This one we're going to do it in decimal dimensions. So that is how we build our negative build